When preparing fresh blood for colony-forming unit assays, also known as CFU assays, it is critical to remove the red blood cells from the sample. Red blood cells can cause background in the assay plates, making it difficult to detect colonies. Some colonies may be masked or obscured by the contaminating red blood cells and may be missed during counts. Another issue is that areas of dense RBC accumulation could be mistaken as colonies, resulting in false positives. Depleting the RBCs results in a much clearer background, making it easier to accurately count and classify the colonies. RBC clearance is particularly important when using an automated imaging device for counting colonies, such as the STEM-Vision. But it is also helpful when performing manual colony counts. It is important to deplete the contaminating RBCs when performing the 14-day CFU assay using Methicult and the 7-day CFU assay using Methicult Express. Some labs can only spare very small volumes of samples for CFU assays. These labs may be concerned that further processing the sample will result in cell loss or inaccurate results. To address this concern, Stem Cell Technologies has developed a protocol for removing RBCs from small volume samples using HetaSep. This procedure requires only 50 microliters of blood. HetaSep works by aggregating the red blood cells into long chains, or rouleaux, which increases their sedimentation rate. Using this protocol, you can achieve more accurate CFU counts with fewer false positives and fewer missed colonies compared to samples which have not been cleared of RBCs. Using HetaSep does not result in a significant loss of hematopoietic progenitor cells. In fact, the average recovery of CFUs in HetaSep cleared samples is 97% compared to uncleared samples. In this video, we will demonstrate the protocol for using HetaSep with small volume blood samples to deplete RBCs prior to CFU assays using Methicults. Please note that this protocol is designed for 50 microliters of blood, but it may be possible to use other volumes too. If you are using different sample volumes, please email Stem Cells Technical Support. The first step in the HetaSep small volume protocol is to determine the total nucleated cell concentration in your starting sample. We recommend using 3% acetic acid with methylene blue and a hemocytometer to count the cells. An automated cell counter can also be used. For more information about cell counting, please see our technical video for performing both a nucleated and viable cell count. For the HetaSep small volume protocol, use a 0.5 ml Eppendorf tube. Add 150 microliters DPBS with 2% FBS, 50 microliters of blood sample, and 40 microliters of HetaSep. Adding the reagents in this ratio will give you a dilution factor of 4.8. This is calculated by dividing the total diluted sample volume by the original sample volume. Mix the diluted sample in the tube using a micropipette. Avoid creating bubbles and do not vortex or invert the sample. Place the tube in a 37°C incubator and incubate for 15 to 20 minutes. Do not exceed 20 minutes, as this could result in lower cell recovery. After the incubation, the sample will be separated into 2 layers. The red blood cell pellet will be clearly visible at the bottom of the tube. The size of the RBC pellet can vary depending on the hematocrit of the blood sample. The upper phase of the separated sample contains the nucleated cells, including the CFUs. Please note, the color of the upper phase may be more or less pink depending on the sample type. For optimal recovery, collect the whole upper phase, but take care not to disturb the red blood cell pellet. Hold the tube at eye level and place the tip approximately midway through the upper phase above the RBC pellet. To aspirate the upper phase, slowly move the tip downward toward the RBC pellet to collect the whole upper phase. Place the upper phase into a new tube. This is your RBC depleted sample containing only the nucleated cells. When aspirating the upper phase, it is important to ensure that you don't disturb the RBC pellet. The final step is to calculate the cell concentration of the RBC depleted sample. Divide the cell concentration of the starting sample, calculated previously, by the HetaSep dilution factor. If you recall, we previously calculated that the dilution factor is 4.8. For example, if you have a starting cell concentration of 5.0 times 10 to the 6 cells per mil, then the cell concentration after HetaSep will be 5.0 times 10 to the 6 cells per mil divided by the dilution factor, 4.8. This gives you a cell concentration of 1.04 times 10 to the 6 cells per mil. You are now ready to set up the CFU assay using Methicult or Methicult Express. For more information about HetaSep or any of Stem Cell Technologies products, please visit stemcell.com or contact technical support.